Hi, I am Anurag Datta, your instructor for today. Today, we will learn about how magnetic field is produced. Let's have a look at the topics we'll cover today. So, what is a magnetic field? A magnetic field is a vector field in the neighborhood of a magnet, electric current, or changing electric field in which magnetic forces are observable. A magnetic field can be illustrated in two different ways: magnetic field vector and magnetic field lines. Then, what are magnetic field vectors? Well, the magnetic field can be mathematically described as a vector field. The vector field is a set of many vectors that are drawn on a grid. Magnetic field lines are a visual tool used to represent magnetic fields. They may be represented by continuous lines of force or magnetic flux that emerge from north-seeking magnetic poles and enter south-seeking magnetic poles. Magnetic fields are produced by moving electric charges. Everything is made up of atoms, and each atom has a nucleus made of neutrons and protons with electrons that orbit around the nucleus. Since the orbiting electrons are tiny moving charges, a small magnetic field is created around each of them. These magnetic fields have a specific orientation or direction. This orientation is called the atom's magnetic moment. All of the atoms in an object act like several tiny magnets. In most materials, all of these moments face random directions and they all cancel each other out, and there is a net magnetization of zero, which means the object will not be a magnet. Now let's have a look at some key points regarding magnetic moments. Number 1. A magnetic field describes a volume of space where there is a change in energy. Number 2. A magnetic field is produced whenever an electrical charge is in motion. And number 3. The strength of the magnetic field is called the magnetic moment. What is the effect of magnetic field on a charged particle? A charged particle that is moving with velocity v in a magnetic field B will feel a magnetic force F. Since the magnetic force always pulls sideways to the direction of motion, the particle moves in a circle. Fleming's right-hand rule. Let's think if a conductor is forcefully brought under a magnetic field, then there will be an induced current in that conductor. We can find the direction of this force using Fleming's right-hand rule. In this rule, the thumb is pointed in the direction of the motion of the conductor relative to the magnetic field, that is F. The first finger is pointed in the direction of the magnetic field, B. By convention, it's the direction from north to south magnetic pole. Then the second finger represents the direction of the induced or generated current within the conductor, V. As we know from Faraday's law of electromagnetic induction, whenever a conductor moves inside a magnetic field, there will be an induced current in it. In electromagnetics, the term magnetic field is used for two distinct but closely related vector fields denoted by the symbols H and B. The magnetic field strength, H, is measured in the SI base units of ampere per meter, while the magnetic flux density, B, is measured in Tesla in SI base units, kilogram per second square per ampere, which is equivalent to Newton per meter per ampere. In a vacuum, the two fields are related through the vacuum permeability, by the following equation. Did you know that there are magnetic fields in space? The spiral arms of the Milky Way seem to have some very large-scale organized magnetic field on the basis of studies of large numbers of pulsars and the polarization of their radio signals. So, that was all from my end. Hope you all liked the video. Please let us know in the comments section if you have any suggestions. Cheers!
Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. You can check our other website as well. We have features like YouTube Trends, Twitter Trends, Scientific Calculator, and many more other tools. If you like our video, please like, comment and share. If you have any questions, please comment and we will resolve your query.